Hello everyone, welcome to Coders Camp. We are at 18th day of October LeetCode challenge and the problem we are going to cover in this video is cousins in a binary tree. So before getting into today's problem, I did not post the previous day's problem because we have them covered in our channel already. So if you're looking for problems and I did not post it recently, which means I might have posted it already, I did not want to post them again. So please do check them. So let's get into today's problem, which is cousins in binary tree, which is again an easy category problem where the input given here is a root of a binary tree and two integer values, and we have to return true or false if they are cousins in the binary tree. And in the problem statement, there is also a definition given for cousins in a binary tree, that is, two nodes of a binary tree are cousins if they have the same depth with different parents. So let's understand this with an example. So here is a given example in the problem statement. The problem statement clearly says the root node of the tree starts with the depth 0 and then goes the next level to depth 1 and then to next level as depth 2 and so on. So now the definition of cousins are just said that two nodes said to be cousins if they both are in same depth and different parents. So the first input given here is x is equal to 4 and y is equal to 3. So let's check where they lie in the binary tree. So if you check 4 is in the depth 2 and 3 is in the depth 1, which is actually a different depth, so they cannot be cousins. So let's check the next condition as well. They both should share a different parent. Of course, the parent of 3 is 1 and 4 is 2, so they both share different parents, but they are not in the same depth. So which means they are not cousins. So what could be the possible nodes that are cousins in the binary tree? So let's check the nodes which are in the same depth. So we don't have another node in depth 2, so we cannot find a cousin for node 4. So let's go to one level up. In depth 1 we have two nodes 2 and 3. So they can be cousins, but it has to satisfy the next condition, which is they must have different parents. But if you see here, both node 2 and 3 share the same parent, which means they can't be cousins. So in this binary tree example, you cannot find any cousins. So let's add one more node to the binary tree. So we have added one more node to the depth 2, and so let's take x is equal to 4 and y is equal to 5. The first condition is to check whether the depth of both the nodes are equal. So yes, depth of 4 and 5 are equal to 2. So the first condition is satisfied. The next condition is they should have different parents. So the parent of 4 is 2 and 5 is 3. They share different parents. So the nodes 4 and 5 are cousins. So we are going to return true. So yes, as simple as that. As you're understanding this concept, how are we going to approach this? By the understanding of this concept, you must be clear by now which tree traversal technique to use to this problem. So we have solved many problems using DFS and BFS. Since this problem goes level by level, you must have figured out by now this problem can be solved by breadth first search. So what are we going to do is, we are going to check two factors for every node in this binary tree, and any of the nodes satisfies both the condition, then we are going to return true. If not, we are going to return false. The first condition is if there is a node, then we are going to check the parent of the node and depth of the node. So we are going to check both parent and depth of both x and y, and the parent of x and y must not be equal and the depth of x and y must be equal. So by checking these two conditions, we are going to return true or false. So yes, we have solved enough BFS problems, so I'm not going to explain how the algorithm is actually going to work. You can use either the iterative BFS technique or a recursive BFS technique to find both parent and depth of given nodes x and y. So after finding the values, it is easy to compare. The parent should not be equal and the depth should be equal, and based on the result we can return true or false. So it is again going to use this simple BFS recursive algorithm in this video, and we are going to check for every node whether its left child or right child is x or y, so that we can identify x or y's parent. By checking this, if X or Y is one of the root node's children or the current node's children, then we declare that current node or root as the parent. So we can find easily by this way parent, and also as we go every level, we are going to put a number or keep track of the depth and assign it to the X and Y's depth. So once it is both the things are found, we are going to compare the results and return it. So before getting into the code, this is going to work in big O of n time complexity, as we are using a basic recursive BFS technique, and big O of n space complexity as we are going to make recursive calls for all this. So let's go to the code now. So as I said, we need 4 factors to be found. The first 2 are parent of the nodes X and Y. So let me declare them as a global variable. And then depth of both the nodes. So yes, let's write a helper method to find these 4 values. So this is going to start from 0 and keep track or increment every time at each level. So first let us check the basic conditions. If root is equal to null, then simply return. If not, we are going to check if the current root dot value is equal to x, then we found its parent. So because we are passing its parent every time in the recursive call. So same goes for y. So yes, we are updating these 4 factors every time if we identify the node. And if we did not identify, then we are going to call the function recursively again and again till we find it. So yes, our helper method is done. So let's go back to the main method to call this helper method. As I said, the depth is going to start from 0. So once we call this helper method, all these global variables will be updated. So now it's time to compare and return the value. So we are going to put a condition class which checks the depth are equal and the parents are different. If both the conditions are satisfied, then return true. If not, return false. So yes, that's it. Let's run and try. Yes, so let's submit and try. Yes, our solution is accepted and runs in 0 millisecond. Also, if you see, this problem has been asked in last year July LeetCode challenge. So this month, most of the problems are repetitive. So you can find those videos in the channel already. So thanks for watching the video. Hope you like this video. If you like this video, hit like, subscribe, and let me know in comments. Thank you.